This audiobook is based on our book about a key philosophical principle in medicine, without which a true understanding of human health is impossible. We extend the previously formulated principle of disease optimality to human health and human life, not only at the individual, but also at the societal level. In Chapter 4, we focus on adaptation and homeokinesis as expressions of optimality. We now move from the fundamental logic of control to the ways in which these laws are embodied in the living tissue of our existence. Adaptation is not a passive response to external pressure, but an active process of recalculating internal resources in order to preserve optimality. At this level, we see how the organism converts energy into stability and chaos into directed motion. Here, the central secret of the living becomes visible. Stability is not the same as immobility. Life is a continuous balancing on the crest of a wave, where every breath and every chemical reaction forms part of a global homeokinetic process. Understanding this dynamics allows us to recognize stress not as an enemy, but as an instrument for investing in future well-being. Stress is not an accidental breakdown, but a fundamental basis of life. As Mykola Amosov observed, stress is the necessary load that prevents our regulatory systems from rusting. It is a universal tuning fork that maintains the organism's functional readiness. As long as stressors remain within a physiological range, they act as a regulator that trains the system. Problems arise when optimality is disturbed, when the response becomes excessive inert, or exceeds energetic capacities while being markedly prolonged in time. In disease, stress is transformed into cellized general adaptation syndrome, which, under an optimal course, leads the organism toward recovery in acute states, or toward remission in chronic processes. The classical notion of homeostasis as constancy is an illusion, since no static stability exists in the living world. We are homeokinetic systems, in which equilibrium is a continuous, controlled motion. The organism is constantly altering pressure, temperature, and metabolite levels, preventing them from crossing critical thresholds. Stability here is not a frozen state, but a range of governed oscillations. The limits of stability of a homeokinetic system define how wide a maneuver the organism can afford without structural breakdown. When these limits are exceeded, the system must either discover a new level of organization, a new optimum, or pass into a state of decompensation. Health is the capacity of the system to maintain this homeokinesis under control even under high load. Adaptive mechanisms unfold hierarchically, securing optimality at every level. At the cellular level, this means switching enzymatic pathways and activating DNA repair systems. At the level of the organism, neuroendocrine and immune responses are recruited to redistribute energy among Anakin's functional systems. At the level of persons and their communities, adaptation assumes a social form. By forming groups and creating technologies, we expand our shared adaptive corridor. The evolution of adaptations is the path from simple biochemical reactions to complex collective decisions. At each of these levels, the system survives only when the configuration it finds allows it to keep adaptive cost within the limits of available resources. Any disturbance of equilibrium signals that the old optimum no longer works under the new conditions. Monitoring stress markers during illness, from heart rate variability to hormonal profiles, immune parameters, and other indices, is an assessment of whether the organism is following an optimal path to recovery. The diversity of possible deviations from the norm suggests the specific pattern of failure in control. With any intervention, we must assess not only subjective relief, but also whether it is effective in a systemic sense. Has it redirected stress into the channel of optimal change? If the indicators return to a state of controlled homeokinesis, the system has been guided onto an optimal trajectory. If the markers instead show chaotic oscillations, the adaptive cost of the intervention is too high for the person's well-span. We will be grateful for your likes and for sharing information about this audiobook with others.